Okay, this is our introductory lecture on psychological science. So the first thing you need to note here is that psychology is a science. You may be taking this course as a social studies credit, but you should know that psychology is based on scientific principles and falls quite squarely in the realm of science. So why do we need psychological science? Well, it helps us to avoid some tendencies that can lead us astray, such as hindsight bias, which is that I knew it all along kind of phenomenon, and overconfidence. Hindsight bias might lead us to place blame unduly. For example, after the Virginia Tech shootings in 2007, there was a lot of criticism of how the school reacted, along with claims that they should have seen it coming. Of course, no one can predict occurrences like this, and as the events were unfolding, people were making decisions in real time based on what they knew at that time. In hindsight, certain things seem obvious, like locking down the campus immediately, but it was not so obvious at the time. Psychological science also helps us to maintain a scientific attitude. We should be skeptics of everything. A scientific attitude is one in which we maintain that nothing is proven yet. There are only very strong indicators. Certainly the theory of gravity seems to be a very strong one, and I'm happy operating on the assumption that it is true, but I maintain that there are other possibilities which further research may uncover at some future date. This leads us to critical thinking. Question everything. Examine all assumptions, evaluate the evidence, and assess your conclusions. This is something that we will be doing throughout the course. So why care? Why should we care about these things? Well, first and foremost, research methods are the foundation of critical thinking. So what does that really mean? Well, if a new report comes out stating something like researchers have found a relationship between the occurrence of ADD, ADHD, and the number of hours spent watching television, then the first thing we would want to look at is the research methods used to determine that assertion. If the assertion is based on shaky research, perhaps they used a biased sample or there was no control for experimenter bias, then we would question the value of the findings. Psychological science also separates science from sort of pseudo-psychology. What I mean by this is that real psychological research is distinctly different from those sort of relationship surveys that you see in the back of Vogue or Cosmo magazine. If you fill out a little survey and it tells you that in order to find your Mr. Right, you should wear more red, well, that's not good science. That's magazine publishers filling pages with games to get you to keep buying their product. It is also useful in thinking critically about everyday issues. Considering the state of politics, the economy, social issues in this country today, it's probably worthwhile for all of us to be somewhat critical about the things we hear in the media. And finally, it's a highly marketable skill. Being able to do good, solid research will help you in almost any field you go into. Certainly, it's something that you're going to have to do if you're planning on going to college. So, our overview for this lesson is as follows. We'll talk about the science of psychology, which we've already done a little bit. We'll define it, compare it to other ways of knowing. We'll define and apply some basic concepts, talk about various scientific methods, add in a few more advanced terms, and then talk a little bit about ethics, and then lead into our next lecture on data analysis. So to define psychological science, if we say that science is the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experimentation. Psychology, of course, is the scientific study of the human mind and its functions, especially those affecting behavior in a given context. If we put those two together, then we have the scientific study of human behavior. Psychological science is objective, it's testable, and it's falsifiable. It is systematic in its approach using sound research methods. It strives to be precise in its language, so we avoid using terms like being smart, and rather we try to use precise terms like the subject's intelligence quotient. We can use both qualitative and quantitative methods, and we'll talk more about what those are shortly. And finally, psychological science is always subject to public scrutiny, and this is a good thing. For example, you may have heard of the Mozart effect, which is an assertion that if you play classical music to your infant, or even before the child is born, then the child will be more intelligent. That assertion was based on a single report that has never been replicated. That is to say that no one else has ever come to the same conclusions despite several further studies. And yet, people will still continue to purchase CDs that claim to improve your child's IQ through classical music. Psychological science varies from other forms of knowing in some very important ways. For example, it does not rely upon tradition. There is no claim that we should continue to do things a particular way only because that's the way it's been done in the past. It does not rely upon expert opinion. Certainly, psychology is rife with experts voicing their opinions, but the understanding is that even their opinions are open to further scrutiny. And psychological science is not dependent on personal experience. Anecdotal evidence may be used to describe a phenomena, such as memory retention or memory failure, but the anecdote does not prove the theory. The theory, or research, explains the experience. And finally, inductive or deductive reasoning may be used in psychological science, but must be used carefully when attempting to find any kind of causation, and in fact can sometimes lead to false assumptions. So how does psychological science differ from these other approaches? Well, psychological science requires data collection. You have to do a study, you have to gather your information, gather your data. It's open to criticism, so everything that is researched must be published and then peer-reviewed in various journals. Psychological science is an ongoing process. The research does not prove a hypothesis, it merely adds to the body of evidence, and thereby contributing to that theory. Okay, so let's talk about some basic terms and concepts here. We've used these terms already. So a theory is a scientific explanation of some phenomena. It must meet scientific criteria. It generally explains multiple phenomena. So evolution, gravity, Piaget's theory of development, for example, or a theory of cognitive dissonance. On the other hand, a hypothesis is an explanation about a particular situation that leads to testable predictions. Another term that we'll use a lot is variables. Hopefully you've already had some exposure to this, but variables are things that we manipulate, things that we control, things that we measure. We can do this in qualitative or quantitative research. We use independent variables and dependent variables. So the independent variable is that which we are changing or manipulating in some way, and the dependent variable is that which we are measuring for change as a result of our manipulation of the independent variable. We'll also talk about true experiments or true variables versus quasi-independent variables. A true independent variable is one that is ascribed or that the researcher assigns to the subjects. A quasi-independent variable is one that's already present, and I'm going to show you a couple of examples of those in a few minutes. So what are some of the limitations of the scientific inquiry method? Well, it cannot address ethical or philosophical questions. So if we're looking at psychology, psychological science can tell us why we behave in a particular way, but it can't tell us whether we should behave in that way or not. The scientific inquiry also provides a very simplified view of reality. So if we were looking at research done in a laboratory, the information we get from that research cannot always be generalized to the general public. Not all data collection instruments are perfect. So if we're testing people's intelligence and we're using intelligence tests, there may be some error in those intelligence tests. And our procedures are governed by ethical guidelines, so not all of the problems can be researched because of ethical concerns. So we have to talk about some ways of classifying our research. And here you've got to be careful of some of these terms. So don't take basic to mean simple or elementary. Basic research is foundational to define or refine a theory. Applied research is used to determine the usefulness of a theory. So we have now largely decoded the human genome, which is all very well and good, but what do we do with that knowledge? And of course, people are doing some great research in this area to prevent or treat things like Alzheimer's disease or Parkinson's disease and many other major health issues. And we can also classify research into quantitative and qualitative. So quantitative research argues for one objective reality that exists independent of the observer, in which the researcher strives to remain objective and detached. For example, in a quantitative research study on the relationship between IQ score and GPA, the researcher would administer an IQ test to a sample population and then compare them to the subject's GPAs. They might do this over a period of years to measure rate of change or stability of scores or something like that. The researcher would not be particularly concerned about each subject's background history, other than perhaps a few variables like birth weight, premature birth, fetal alcohol syndrome, or other clinical issues. A qualitative researcher, on the other hand, might be more concerned with the subject's understanding of intelligence and how much importance they place on GPA. This researcher might argue that it is more important to tell the subject's story and how intelligent they feel, or that their intelligence can only be measured by success in real-life endeavors. Both are certainly valid measures, but as you can see, they're distinctly different. So generally speaking, and please keep in mind when you're looking at this slide that there's always exceptions to this, but in general, when we're talking about the type of data collected, in quantitative research, it's always numerical. We quantify everything. In qualitative research, it's more narrative and visual. So if we go back to our earlier example, and we're looking at a particular phenomenon such as intelligence, quantitative research, we need a number. We need an IQ score, and therefore we have to administer an IQ test. In a qualitative research, we're not really looking at a number. We might look at whether the person sees themselves as being intelligent, or do other people see them as being intelligent, or how do they define intelligence. And that's not a number, that's sort of a narrative thing. In quantitative research, we manipulate the context. So again, if we're talking about intelligence and we've decided that we're going to use the IQ as our number to measure intelligence, we need to do an IQ test, and therefore we've manipulated the context, because most of us don't go around sitting in laboratories taking IQ tests every day. In qualitative research, we aren't manipulating the context. We're looking at it sort of in real life, in a real life situation. Generally speaking, quantitative research depends upon a large sample size. The larger your sample size, the more reliable your results. Qualitative research, on the other hand, can be done with very small sample sizes. And sample size being the number of people, if we're doing psychology, the number of people that we are researching. Quantitative research relies on statistical procedures. So once we have all these numbers, all this quantifiable data, we can analyze it using various statistical procedures, and that's what we'll talk about in our next lecture. Qualitative research, on the other hand, relies on categorizing and organizing data into patterns. What types of people see themselves as intelligent? In what situations do people grow up thinking of themselves as intelligent or not? And in quantitative research, there's very little participant interaction, meaning the participant, the subject, and the experimenter do not interact in meaningful ways. And that's on purpose. That's to limit bias, things like that. In qualitative research, there's a lot of participant interaction. It's extensive. We're sitting down interviewing, talking to people. Of course, there has to be an interaction there. So again, these are some generalizations, but you'll probably find numerous exceptions to them. So in practicing psychological science, we use a scientific method, or methods to be more precise. And three basic methods will be discussed here. We'll talk about descriptive methods, correlation methods, and experiments. Our three classifications of scientific methods then are descriptive methods, which can be either qualitative or quantitative. They describe, for example, the case study, or doing a survey, or doing a naturalistic observation. Predictive methods are quantitative only. We have to have a numeric value. And with predictive methods, we're looking for a correlation between two things. two variables. And then finally, explanatory methods that again are quantitative only. It can either be true experiments or quasi-experiments, and we'll go in more in depth into those in a minute. So, what are descriptive methods? You probably already have experienced some of these, or you're familiar with some of these. For example, case studies. You may have read some of the Oliver Sacks books. For example, The Man Who Mistook His Wife for a Hat, in which he discusses various case studies of patients he's had or patients other people have had. You may have read about Luria's S, a patient who had incredible memory, or HM or Clive Waring, all of which had some sort of memory function or memory dysfunction. These are case studies. Descriptive methods also use surveys, so you see people going around surveying, do you like Pepsi over Diet Pepsi, or Pepsi over Coke, or something like these. These are surveys that we fill out that describe something. And then natural observation, naturalistic observation, so we think about observing, anthropologists observing a group of people, and that would probably be a qualitative method. But that's an example of a naturalistic observation. And then interviews, narratives, focus groups, things like these. These are all qualitative methods of descriptive research. There are strengths and weaknesses to descriptive methods. So descriptive methods are a great source of ideas for further study. For example, why did Luria's S have such incredible memory? What factors determine the effectiveness of our memory? Even basic questions such as how does memory work? They create these ideas. But descriptive methods cannot establish causation, and attempts to do so are largely based on conjecture, which is not scientifically sound. Surveys are great ways to collect large amounts of data, but we have to be careful of how we go about gathering that data. For example, is our sample representative of the population we want to study? Is there a bias in how we ask the questions on the survey that could lead to inaccurate answers? So if you stand outside a McDonald's and you're doing a survey on how people feel about eating healthy, well, the sample that you're going to get from that particular location as you gather data is going to be a little bit biased. And finally, naturalistic observations are great for viewing the phenomena in its environment. And we see how a person suffering from schizophrenia actually behaves and reacts to real-world stimuli, but it doesn't explain the causes of schizophrenia to us, or even why that subject reacts in that particular way, only that they do. And of course, naturalistic observation takes a long time. Naturalistic observations are done over periods of months or even years. So these are some of the drawbacks, some of the strengths and weaknesses to descriptive methods. So there are various methods for doing descriptive research, and they provide us with some great information. But the drawback is that descriptive methods cannot establish causation or even correlations. And that brings us to predictive methods. So the purpose of predictive research is to establish correlations between two dependent variables. Doing this yields what we refer to as a correlation coefficient. And because the correlation coefficient, or because the words correlation and coefficient both begin with the letter C, mathematicians often refer to it as R. Mathematicians are great at doing logical proofs, but can't always apply logic when needed. R always yields a score somewhere between 1 and -1. A score of 0 would indicate no relationship between the variables, and a score of either 1 or -1 would indicate a complete or total relationship. So two variables, such as a person's shoe size and their foot size, would yield a strong positive correlation. As the foot size increases, so does the shoe size. Something that yields a negative correlation might be age and mile runtime. Certainly at some point, as age increases, runtime decreases. I suppose really this would yield a curve if we graphed it out, but you kind of get the idea. So here are some examples of correlation coefficients. In this case, we have a moderately positive relationship between two variables. Students' scores on exam 1 and then their scores on exam 2. It's a moderate correlation. We see an R score of 0.66, and if we look at the graph, we can see that generally speaking, if a student did well on the first test, they were likely to do well on the second test and vice versa. There are a few students who either did poorly on the first test, for example, let's see if we can. So if we have a student who did poorly on the first test, so let's say someone who did bad on the first test, somewhere along here, but then improved on the second test. So we have this individual. And we can always have somebody who did very well on the first test, exam 1 did very well on the first test, like here, but then their score dropped on the second test. So they scored a 50 on the first test, or 52 on the first test, but then their score on the second test dropped to below 40. But generally speaking, if we look at this with our R score of 0.66, we can see that generally speaking, if somebody did well on the first test, they were likely to do well on the second test. So this is a positive correlation. So here's another example where we see a moderate to weak negative correlation. So we have a R of negative 0.52, so a moderate to weak negative correlation, and this is between the number of shoes owned and a person's GPA. So we can see that as GPA increases, as GPA goes up, right, the number of shoes one owns decreases. So we have, for example, these three individuals here who have very high GPAs but don't own more than about 20 pairs of shoes. Now notice this is a pretty small sample size. I think we have n equals about 15 people here, so it's a small sample size. And in this case, we can measure the strength of the relationship and we can make predictions based upon that. So as a teacher, I may see a student score low on a pretest, and therefore I can predict that without intervention they will score low on the unit exam. If we go back to our earlier example, exam 1 to exam 2, and seeing that, I will say, okay, they scored low on the first test. I know that generally speaking, if you score low on the first test, you'll score low on the second test, so I'll take measures to intervene. But we have to avoid sort of making that classic mistake of thinking that correlation yields causation. In this case, nobody would claim that the number of shoes you own actually determines your GPA. But according to these 15 people, there seems to be a weak relationship between the two. And yet we often see people making this mistake, especially in media reports and other places, but particularly in regards to health-related issues. So here's one report that I pulled from a website. I think this was maybe from Newsweek. And the title indicates that premature birth results in mental illness. But if you read the actual report, what they showed is that there is a relationship between premature birth and the occurrence of mental illness, but not that one leads to the other. There may be a third factor that causes both. Perhaps there's a genetic marker, or there's environmental causes that lead to both premature birth and a risk of mental illness. So there's correlation, but not necessarily causation. Here's another great one from health.com, or a terrible one really, that seems to claim that obesity leads to lower school performance. Well, again, the study, if you actually read the study, it didn't find that. They showed that there was a relationship, but no causation. There may be, and probably are, a whole slew of environmental, social, genetic components to this particular relationship. But the title seems to suggest that it's the obesity that affects the school performance. And that's not what the study showed. So this is another classic example of people making the correlation-causation mistake. So that's descriptive and predictive methods. Finally, we have explanatory methods. These are true experiments and quasi-experiments. And again, don't think that quasi means less than or not valid in some way. It's a reference only to the way in which we establish the independent variable. Just as a review, the independent variable is what the experimenter manipulates or changes, and the dependent variable is what we measure as a result of that change. So in a true experiment, the researcher assigns the independent variable to the experimental group. In a quasi-experiment, the researcher controls for the independent variable by assigning subjects into control and experimental groups. So let me show you what that looks like. Here's a sample true experiment. So in this experiment, I want to study the effects of sleep deprivation on memory. So I take a random sample of the population I want to study. And the population I want to study is all 18 to 24-year-olds. I make sure that they are otherwise healthy and do not suffer from any sleep-related disorders that could skew my results. I take half of my subjects and I try to ensure that they get roughly 8 hours of sleep. So my control group, I make sure they get 8 hours of normal sleep. My experimental group then, I take that half of the group and I only allow them to get 5 hours of interrupted sleep. So maybe I wake them up every hour or something like that. And this is my experimental group because I'm changing or manipulating the independent variable, which in this case is hours of sleep. And so my independent variable is hours of sleep. Therefore, my dependent variable is going to be performance on a memory test. So I take both groups, give them both the same memory test. And my hypothesis here is that there's a positive relationship between the hours of sleep and the performance on the memory test. This is a true experiment because I, the researcher, assigned the independent variable to the experimental group. So here's an example of a quasi-experiment. And it seems very much like the previous example, but it's different in some very important ways. So here the population I'm wanting to study is people who suffer from sleep apnea. So I'm going to take a sample of people, a random sample of people with and without sleep apnea. Those with sleep apnea become the experimental group, and those with no sleep apnea become the control group. I'm going to measure both groups, just like I did on the previous experiment. I'm going to measure both groups with the same memory test after a night of normal sleep, normal for them. So my independent variable then becomes the presence of sleep apnea, and my dependent variable, just like before, is performance on a memory test. And my hypothesis is going to be that those with sleep apnea will have a lower performance on the memory test when compared to people with normal sleep patterns. This is a quasi-experiment because the independent variable, the presence of sleep apnea, was already ascribed. I, the experimenter, cannot give someone sleep apnea. All I can do is control for it in this particular way. And then in later lectures we'll talk a little bit more about random sampling and random assignment. In a random sample we pull people randomly from the population we wish to study. So again, if I want to study 18 to 24-year-olds, I would gather a random group of people who meet that criteria. If I want to do a true study, then I would randomly assign half of those people to my sample, to my experimental group, and half to the control group. And we'll talk more about this as we go through the unit. So experiments have some strengths and weaknesses. We can control for variables, and we can show causation. The number one strength of an experiment is that we can show causation. The problem is that we have to do this in a laboratory environment and then generalize the findings to the population at large. This is what we refer to as external validity. So we are taking what we've seen happening in the laboratory and we're saying, and this would also happen elsewhere in other situations. We are also limited by ethics, thankfully, and have to be cautious of confounding variables that we did not account for. There is also the ever-present danger of experimenter or subject bias. This last point can be controlled for, though, through what we call a blind or double-blind study. So the danger is that either the experimenter observes what they hope to see. Since I hope to prove that sleep deprivation causes memory problems, I may score my experimental group more harshly or allow my control group more leniency in correcting their mistakes when they're taking the memory test. This is going to skew my data. On the other hand, the subjects may expect to see certain results. In our example experiment, the subjects will pretty quickly figure out the purpose of the experiment, right, if it hasn't already been explained to them, and may expect to perform lower on a memory test, and therefore they do. This is also referred to as the placebo effect, which we'll talk about a lot more later on. Both of these forms of bias can be controlled for through blind procedures. So in the first case, the test administrators would not know if they are testing or scoring the control group or the experimental group. So I would hire somebody from the outside, they would administer the memory test for me, and they don't know if the person taking the memory test is sleep deprived or if they're in the control group. And in the second case, the subjects would not know if they are in the control group or the experimental group. And this is always done in drug trials, where the control group is given a sugar pill that has no medical effect, known as a placebo, while the experimental group is given the actual drug. And only the researchers know which group the subject is in. When both of these procedures are implemented, then we have what we call a double-blind procedure. And this is the best way to avoid bias. So finally, just some advanced terms that are going to come up later on. Operational definitions is a term that you'll probably read about in your textbook, and that's defining a term through explicit procedures or observable behavior. And again, going way back to the beginning, that's the difference between using the word smart and intelligence as defined by an IQ test. Reliability is the consistency, for example, in conditions and criteria. Do we administer the test the same way to the subjects every time? And then finally, validity. We have internal validity, which is the lack of confounding variables. If we have good internal validity, then we can say that one variable causes another, and we can be fairly confident in our causation. And then external validity, generalization to the real world. What we see happening in the laboratory, we feel fairly sure is what would happen in real life, and then we would have high external validity. So the next step then is to take a short quiz, which you will see in Blackboard, and test your understanding of the topics covered here. The quiz can be retaken up to 3 times, so if you have trouble the first time, you can go back and review this lecture again and retry. If you have any further questions, we can discuss those in class, or you can always email me, and you have my contact information again on Blackboard.